Hello, welcome. Let's try to solve another Leetcode problem. 2237. Count positions on street with required brightness. So the problem is that we are giving a line. So in the line there will be a line of numbers. It is index. It is index from 0 to n minus 1. So for example, if n equal to 5, it means the index is going to be starting from 0 to n minus 1. So this is the first position, and this is going to be the last position. And we are also giving a lights array. So the lights array just means the position and range. So for example, the first position is going to be at index 0, and the range is going to be 1. So the radius is going to be 1, so it's going to be coming from here to here. Yeah. And also for the second one, so the position is going to be 2, and the range is 1, so it's going to be from 1 to 3. And for the third one, the position is going to be 3, and the range is 2. It means it's going to be starting from 1 to 5. But according to the value of n, so the index is going to be starting from 0 to 4. So we are only choosing these areas. It's going to be starting from 0 to index 4, but we will not include other areas. Yeah, so this is the only difference. What we are going to return is that we're going to return the number of positions I on the street between 0 to n minus 1 that have a brightness of at least requirement I. So it means definitely we're going to use this description of the lights to calculate a difference array. So after calculating the difference array, we're going to check the prefix sum of the difference array, and then we're going to check its numbers inside of the prefix array after the difference array calculation. So if it is more than or equal to the requirements for each of the index, so we're going to count it as 1, otherwise we're going to count it as 0, and finally we just need to return the number of counts. I think the only difference is that for this difference array problem, our range, there's a boundary for the range, and it is given inside of the description. Yeah, because from here, so this light I is the present range, so it's indicated there is a street lamp at presence I that lights up the area. So we just need to turn the normal difference array to this kind of a formula. After that, we can solve the problem. Yeah, so it means if we were to, for example, at this presence, if we were to go to the left, we can never have a negative value. It has to be 0 because it will be bounded left to 0. If we were to go to the right, it can never be a position like the position plus range I if this is bigger than n minus 1, but we will bound it to n minus 1. So for example, if it is 5, so we will not choose 5. We just need to choose this number 4. It will be bounded to 4. This is because this is n minus 1. Yeah, so we will ignore all those values. Yeah, but so we need to be careful. But even we will not. I think we had better bounded the values to the index 0 to 4 because this is easy to understand and it's also easy to calculate. Yeah, so if you don't want to bound it, this is also okay, but let's first try to bound it together. So for the difference array, we're going to prepare f0 to n plus 1, and then we're going to check the positions and the range, so inside of the lights. So we're going to prepare the start and the end position. So according to the formula, it's going to be the maximum here. Let's just copy. So it's going to be 0 to this one. Let's just copy it. So we're going to use here, we're going to use P to R. And the end position is going to be the minimum of n minus 1 to P plus R. Yeah. Now we just need to use F with the start position, gonna plus equal to 1, as it is inclusive, so the end position plus 1 would minus equal to 1. And after that, we can check the prefix sum of the difference array. So it's going to be list accumulate with this F. So finally, we just need to count how many of them. So we're going to use A more than or equal to B. So So for this AB in zip of the prefix sum with the requirements. Yeah, so this is the requirement. Yeah, basically this is okay, but we had better take out the last value because we don't need it. So we're gonna take out the last value. So this is F, and from here, and we're gonna take out the last value inside of the difference array because the last value is only prepared for calculation, but we don't need it. Yeah. Now let me just run it to check. As you can see, it works. Now let me submit it. Yeah, as you can see, it works, and the speed, I think it is okay because this is basically ON time complexity, and N is just this number. Yeah, we even don't need to have this -1 because in Python, this zip is just to choose from the beginning to the longest and to the shortest because the shortest is bounded by the requirement, so it is okay. We don't need to. Yeah, if we were to use a zip, we don't need to take out the last one. I believe it also works. Let's just try. As you can see, it works. Yeah. Maybe. So if we don't want to bound it, what's gonna happen? Let's just try because we only focus on the range of interest ROI. Yeah. So this is the. Let me use a clear and use another color. We only focus on the ROI area. It is called the range of interest area, so it's going to be in this area. So we can calculate all the values, but for difference array, our index is just starting from 0 to n-1. But here we're going to have negative values. How should we deal with that? So we have to bound it to 0. But for the right side, it is okay. Now let's just try to, let me just try to bound it to the left side because definitely we're gonna start from index 0. But for the right side, it is okay. Let's just take this p plus r. Yeah, because we don't need it. Yeah, because finally we just use this zip to calculate the final result, so it should be okay. Even we don't use the minimum, it should be okay. Yeah, because we use the zip and because we use the prefix according to the difference array calculation. I'm not sure. Oh, so the index will go out of a range. Yeah, because of here, because of this is the end prison. Maybe we want to choose a bigger value. Let me try to find a bigger value. So for here, this bigger value is gonna be really big, and because it depended on the maximum positions and the maximum radius, maximum range. Yeah, let's just check the value. So the range is gonna be 10 to the power of 5, and the position gonna be this. It is also 10 to the power of 5. So it means from here we need to choose another value. So it's gonna be 2 times 10 to the power of 5. Yes, let's just plus a 1. I think this one, in this way, it should be okay because here we don't need to check the index should always inside. Yeah. Now let me submit it. Yeah. So this is also another way of solving the problem. But as you can see, for this one, each of the time complexity is 10 to the power of 5. Yeah. But before that, the time complexity is just it can be much smaller. Yeah. But if you don't want to bound it to minimum, yeah, you can still use this way to solve the problem. I mean, any way is okay. We just need to get the final result. Thank you for watching. See you next time.